This is Unit 6, AP Calculus, Day 48 notes. Our objective is to find antiderivatives, indefinite integrals of polynomial type and trigonometric functions. So for Day 48, Part 1, finding antiderivatives of polynomial type functions. And it's just what it sounds like. It's just undoing a derivative. So if you had to explain to someone how to find the derivative of a polynomial type function, what would you say? Well, if we think of the power rule, multiply the power by the coefficient of each term, and then subtract 1 from the power of each term. Well, let's extend that. To find the antiderivative, you would do the opposite of each one of those operations and in the reverse order. Therefore, to find the antiderivative of a polynomial type function, add 1 to the power of each term, and then divide the coefficient of each term by the new power. So now the antiderivative of function f of x is denoted by the notation, and you see the little symbol, little squiggly line, f of x dx. The f of x is the integrand, and the dx is the variable of integration. So we read that, the integral of f of x dx. So when finding the antiderivative of a function, you are finding the function of which f of x is the first derivative. This will enable us, if given f prime or f double prime, to be able to find f. However, if the integral of f prime of x dx equals f of x, what problem do you foresee? And think about this for a second, and let me pause here. So when we took the derivative of x cubed, we got 3x squared. So now, to undo this, if we did x cubed dx, we just learned, okay, this is just going backwards. So I add 1 to the exponent and then divide by that new power. And that's just what I started with. All right, that makes sense. The only problem is, what is the derivative of x cubed plus 8? What is the derivative of x cubed minus 6? What is the derivative of x cubed minus 113? We'll notice all of these have a derivative of 3x squared. So when I go backwards, there's no way to tell that there was this constant. So what do? We now know that although the integral of f prime of x dx should be f of x, there's no way of knowing if the original function had a constant term or not. Therefore, the integral of f prime of x dx is equal to f of x plus c. So that c is an unknown constant that must always be added. And this is why we call this the indefinite integral. So we're taking the antiderivative, which is the integral, but it's indefinite. There's an infinite number of solutions. We don't know exactly which one we're looking at. So just like that example, if I took the integral of 3x squared, I could get x cubed. I could get x cubed plus 8, x cubed minus 6, x cubed minus 113. Those would all be the integral of 3x squared. And actually, I just wrote that backwards. Let me come back here. This should have been the integral of the derivative, 3x squared dx. And I did go backwards. I added 1, then divided by the new power, and that's where I got to the x cubed. So this was my original function. And then down here, we took the integral of the derivative, and we got our original function, but we just have to know that we have to add a constant to it. Okay, this is for an indefinite integral. So let's practice some of these. And just like when I'm taking the derivative of a polynomial function, I can break those into parts. Same thing when I'm doing the integral. And we'll get a little more specific with the properties later on. But for right now, so the integral of 3x squared, I add 1, 3x cubed, divide by the new power. 2x the first becomes 2x squared, divide by the new power. 3 is really understood to be 3x to the 0. So I add 1 and then divide by 1. And whenever we take the indefinite integral, and again, we were taking this with respect to x, but either way, I need to add a constant. So there's my plus c. So now I can rewrite this. So those cancel out. So my final answer is x cubed plus x squared plus 3x plus c. And again, we could try that. Any function, I take the derivative of x cubed, that's 3x squared. Take the derivative of x squared, that's 2x. Take the derivative of 3x, that's 3, and any constant would have a derivative of 0. So when I took the derivative of this, I would end up here, and that shows the antiderivative, or the integral, leads us to this function with the plus c. All right, let's try the next one. First thing I want to do is make it look polynomial-like. So we have x cubed over x is x squared, 2x over x is 2, negative 4 over x I wrote as negative 4x to the negative 1. So now let's follow our rule for taking the antiderivative, or the integral. Okay, so x squared becomes x cubed over 3, 2 becomes, which is 2x to the 0, becomes 2x to the first over 1. Now, this is tricky. So this negative 4x to negative 1, when I add 1 to the exponent, that's 0, and then I divide by 0, that's going to be a problem. So anytime we get this x to the 0 over 0, this is going to become a natural log situation. And we'll talk about this in 1 second. So this would be the natural log of x, and we'll rewrite this in a second. And let's think about it. Natural log of x, if I took the derivative of that, was just 1 over x, which is really x to the negative 1. And then when I undo that, taking the integral, it's x to 0 over 0. So that's just something we have to remember. Whenever I get x to 0 over 0, or x to negative 1, the integral of that is going to be natural log of x. And obviously the natural log of f of x is f prime of x over f of x. So anytime we get to an x to the 0 after we do the integral, it's going to be a natural log situation. Okay, and let's just rewrite this. So I get x cubed over 3, or I'm going to write that as 1/3 x cubed plus 2x, subtract. So minus 4 natural log of x and plus c. We always must remember the constant at the end. Okay, let's go on. Why don't you try the third and fourth one, and then check to see how you did against mine. And again, always try to rewrite it first as a polynomial-like function. Okay, so for this one, get it as a polynomial, follow our rule, and then just the last step. Really, the second step in green is correct, but we just want to rewrite it so it looks a little prettier. All right, last one. And again, square root of x is x to the 1/2. And we're going to write this as the integral of 2x to the negative 1/2. And again, the variable of integration is dx. So variable of integration is x. Okay, so we add 1 to the exponent. So it's going to be 2x to the 1/2, divide by the new exponent, new power, and then 2 divided by 1/2 is the same as 2 times 2 over 1, which is 4. So 4x to the 1/2, and we're going to write that as 4 square root of x. And again, we're dealing with an indefinite integral, so there can be an infinite number of possible solutions, so we have to add this constant of variation. So that is the plus c. Okay, that's it for part 1. We will jump in to part 2 in a second.